Chronic venous disease is a very common disease that affects the venous system of the lower limbs and is characterized by a wide range of signs and symptoms. Until now, the pathogenesis of venous dysfunction was not fully understood. New insights have shed light on the importance of venous hypertension and the key role of the leukocyte in the disease process. Let's now travel into the venous system as we have never seen it before. The role of the venous system is to return the deoxygenated blood from the lower extremities to the heart. To counterbalance the effect of gravity, the veins of the legs are equipped with a series of one-way valves that prevent the return of blood flow toward the feet. When these valves are healthy, they function in concert with the contractions of the calf muscle pumps to allow the return of venous blood in an upward direction to the heart. Pathology develops in the superficial venous system when the blood pressure increases and blood flow can be reversed in the lower extremities. When valves become incompetent, they allow retrograde flow of blood and high hydrostatic pressure, which progressively leads to reflux and chronic hypertension in the veins. This can lead to the remodeling of the venous wall, the appearance of varicose veins, and further complications linked to the progression of venous disease. Venous hypertension and changes in the hemodynamics of the superficial veins are in turn transmitted into the microcirculation, causing high venous pressure and increased permeability at the level of capillaries. Damages to capillary endothelium lead to the accumulation of fluids, proteins, and red blood cells into the interstitial space, forming capillary edema and inflammation, and may result in alterations to skin and tissues, up to ulceration. Research into the mechanisms of skin ulceration has highlighted the hallmark of an inflammatory reaction, with the crucial role of the leukocytes in microcirculatory changes. In healthy individuals, leukocytes circulate freely in the capillary blood flow. In chronic venous disease patients, abnormal blood circulation and prolonged hypertension favors the capture, rolling, and adhesion of leukocytes onto the capillary endothelium. This leukocyte endothelium interaction is due to the expression of a variety of adhesion molecules on the surface of leukocytes and endothelial cells. In chronic venous disease patients, these adhesion molecules are overexpressed, leading to the increased adhesion and migration of leukocytes into the capillary endothelium. When leukocytes are activated, degranulation occurs and proteolytic enzymes with other toxic components are released, producing a massive inflammatory response at the origin of the microcirculation damaging process. It is by inhibiting this inflammatory leukocyte-induced reaction that Daflon 500 mg protects capillaries and the microcirculation from further inflammation. Daflon 500 mg significantly reduces the expression of leukocyte adhesion molecules, limiting the rolling, adhesion, and migration of leukocytes through the capillary endothelium. Recent findings show that a similar inflammatory process induced by high venous pressure occurs right from the onset of chronic venous disease at the level of valves and wall of superficial veins. In the same way, Daflon 500 mg reduces the rolling, adhesion, and migration of leukocytes into the valves and venous wall. By inhibiting the early leukocyte-induced damage at the level of valve leaflets, Daflon 500 mg protects venous valves from destruction. The inflammatory process is stopped, valves remain competent, the appearance of venous reflux and further complications are prevented.